October 3rd, square roots and radicals. A root is the opposite of an exponent. A square root is the opposite of squaring something. For example, the square root of 16 is equal to 4, and technically also negative 4. Based on that same idea, the square root of 4 is equal to what? Well, if you said 2, you'd be right. Simplify each one as far as it will go. Show all solutions. So the square root of 9, you may think the only answer is 3, because 3 times 3 is equal to 9, but there's another number, and that is negative 3. Because if I take negative 3 multiplied by itself, I also get 9. A more compact way of expressing this idea that we could have a positive 3 or a negative 3 is to use what's called a plus-minus symbol. This means that our answer could be a positive 3 or a negative 3. So for the square root of 144, if you don't know your square roots off the top of your head, which this would be 12 by the way, we can use what's called a factor tree, where we say what are any two factors that multiply together to make 144. And maybe you're not sure, so you pick 2 and 72. And maybe you remember a few things about 72, such as 9 and 8. And from here we break this into 3 and 3, 2 and 4, and from there 2 and 2. This is called a prime factorization tree because we keep factoring until we run into prime numbers. You'll notice that we have 4 2's and 2 3's at the bottom. So if we want to think about the square root of 144 as the square root of 3 times 3 times 2 times 2 times 2 times 2, this is the prime factorization, or 144 broken into only prime factors. And we're looking for pairs, such as a pair of 3's, a pair of 2's, and another pair of 2's. We can pull each pair out as a single number, and our square root ends up being 3 times 2 times 2, which is a long way of getting 12. Remember, of course, that we can either have a positive 12 here or a negative 12, so we can write our answer like so. Try simplifying some of the others. And while we're at it, roots can go bigger. The number on the upper left tells you how many times the answer has to go into what you're taking the root of. For example, since 2 times 2 times 2 is equal to 8, the cube root of 8 is equal to 2. Simplify each as far as you currently can. Show all solutions. So some cube roots are a little more straightforward. For example, we know that 1 times 1 times 1 is going to equal 1. So the cube root of 1 is just 1. And we already covered earlier on that 2 times 2 times 2 is equal to 8. So the cube root of 8 is just 2. But what about some of these larger numbers that we might not know right off the top of our head? Well, let's look at one like 64. Again, we can use this prime factorization tree. If we start with 64, what are any factors we know of 64? 8 and 8 are some pretty common ones to know. And these break down into 2 and 4, or 4 and 2. And those break down into 2 and 2, respectively. Or in other words, if we want to take the cube root of 64, we can instead take the cube root of 2 times 2 times 2 times 2 times 2 times 2, because that is the prime factorization of 64. And since we are taking the cube root, we look for groups of 3. I see there's a group of 3 2's here. I'm going to pull one of those out. And there's a group of 3 2's here. So it turns out my answer is 2 times 2, or 4. 4 times 4 is 16, times 4 again is 64. Does it work with a negative 4? Well, negative 4 times negative 4 is a positive 16, but if we multiply that by a negative 4, it gives us negative 64. So for odd numbered roots, no, the negatives don't work. Try a few more of these.
So on to the back. Radical rule number 1. If you're multiplying two roots, you can combine the terms under a single root. For example, the square root of 7 times the square root of 10 is equal to the square root of 10 times 7, or the square root of 70. So if we were going to simplify the square root of 4 times 12, this becomes square root of 48. Or here the square root of 16. And here the square root of 49. Or the square root of 100. Now in some cases, we are looking at perfect squares, like 16. Why is 16 a perfect square? Because 4 times 4 is equal to 16. Or in other words, there's a number that there exists a number that when you multiply it by itself, you get 16. So this, we're going to get an answer of plus or minus 4, because 4 times 4 is 16, while also negative 4 times negative 4 is 16. There's a similar case for 49. This is plus or minus 7. And for 100, which is plus or minus 10. 48 is a little trickier. For the purpose of this week, we will simply leave it as the square root of 48. But if you wanted to know how to simplify it, I'll show you. So to take the square root of 48, we're going to do a factorization tree again. And what are any two factors of 48? Such as 8 times 6 gives us 48. And we keep going on each branch of this factor tree until we hit a prime number. For example, 8 has two factors, 4 times 2. 2 is prime, so we stop there, but 4 can be broken down further. And 6 breaks down into 2 and 3. So another way of writing the square root of 48 is the square root of 2 times 2 times 2 times 2 times 3. I got these numbers from the bottom of my prime factorization. Because I know I'm looking for the square root, there's actually a 2 there, I'm looking for the second root of 48, I'm going to look for pairs of numbers, like these pairs of 2's. The 3 does not have a pair, so we don't pull it out from underneath the radical. In fact, it stays there. And what happens is we have a 2 times 2 square root 3, or 4 root 3. Because every time we pull out a pair, we only keep one of those numbers. So there's a 2 from here and a 2 from there, and we multiply them together to get the 4, and the 3 stays underneath the radical. You'll learn more about that in Algebra 2. For now, though, the square root of 48 is totally fine.